Good morning, everyone, students. I would invite Prachi ma'am to start the session.
Hello everyone, good morning. How are you all? And I hope you all have revised whatever we have done till now. Yes. So who are all are there in the class? So we have Bhavna, Shravani, Ashrita, Omkar. And then we have some new students. So yes, the first thing that we have to do is just you people mark your attendance by just putting your names in the chat. And by that time you are putting your name, I'll write whatever we did till now, and then we'll solve the question based on whatever we have learned in the board's model of atom. And what are the things that we can know by using this model? So yes, also those are new, you have to reply on, you can see one name Prachi Chauhan. So you have to send your messages on that, or else what you can do is go into the chat and select everyone, and then you can send the messages. Or if you want to send it to me, then you can send it on Prachi Chauhan. So the one with the full name, Prachi Chauhan, on that you send the message. Okay. So all of you put your name in the chat. And yes, today we will be doing the questions, which is very, very important for us. Yes, Umar, Bhavna, good morning. Mahavish, Omkar, Ashrita, Umar. Good morning, everyone. I hope you all are active and just sit with your pen, copy, because today we will be doing the questions. And questions are very important for the chapters which are from physical chemistry, and this is one of them, which is structure of atom, a chapter from physical chemistry. And physical chemistry is more like mathematics. You will have lot of calculation, lot of formulas. Yes. Okay. Okay. So good morning, everyone. So let's begin with the first knowing the formulas for the ones those are new to the class, so that they can also solve the problems. So till now we have learned about the Bohr's model. And yes, for sure you may get one question from this portion. So in this, we first learned he gave the formula for calculating the radius, which is 0.529 into n square by z. Yes, unit is very important, which is angstrom. Then we learn the formula for velocity. So velocity will be equals to z by n into 2.18 into 10 raised to the power 6 meter per second. Now the things that are more important for us in velocities, we must know that velocity is proportional to z by n, right? And your radius for any monoelectronic species, which hydrogen, helium positive, lithium 2 positive, and beryllium 3 positive. So all of them, they will have one electron. Monoelectronic species, right? So here we can say Rn is proportional to n square by z. Now in exam, you may forget whether n was in denominator or was it in numerator. So how you can remember is, this is a simple logic, right? As the value of n increases, the radius will increase, right? For the first orbit, the radius will be this much. For the second orbit, it will be this much. So as I am increasing the value of n, the radius is also increasing. So yes, it will be directly proportional to n square and inversely proportional to z, whereas your velocity with which this electron is revolving around, it will decrease as we move from the lower orbits to the higher orbits. So it is inversely proportional to n. So from this, what I can conclude is, as we move from the lower orbits to the higher orbits, the velocity with which electron is moving around the nucleus will decrease, right? And then we learned about the energy, right? Where we learned that kinetic energy is equals to minus half of potential energy. Now, why I am writing this? Because yes, you have got question which was based on this. Whereas total energy, it will be the sum of kinetic energy plus potential energy. So from here, we can say that total energy is equals to half of potential energy. So if you'll see the previous lecture, you will know how, what formula did we take, right? Now, the other thing is, what is the energy? What was the formula for energy that we find out? So En is equals to minus 13.6 Z square over N square electron volt per atom. So that is the formula for the energy. Let's write in joule also, because yes, in exam sometimes you will be asked to find it in joule. Z square over N square. Now again, the other thing that is important for you is that the energy in the nth shell, right? This is in the nth shell. So let's suppose if somebody asks you to find it in the first shell, so you keep the value of n as 1. Then if somebody says second orbit, third orbit, so on. So En, we can say that it is proportional to z square over n square. Now why I am writing the proportionality relation, that tells me about the proportionality, because sometimes you will not be asked to tell the exact value, you'll just be asked about the ratios. What is the ratio, or how many times is the radius, first radius of hydrogen is to the third radius of the helium positive. So those kind of a question you may get. So these are the things that you have to keep in mind when you are solving the problems, and this is all what we have learned till now, right? Also, we learned about the energy levels for the hydrogen, right? What did we learn? We learned about the energy levels for the hydrogen atom, which it is good if you can learn or remember it for. So what you have to do is just keep it with you and revise it time to time. So it will help you in exam. At least questions related to this you can do directly, right? Then what did we learn? We learned that as the electron is moving from one, first thing that we learned is that at infinity, energy is taken as zero. So any orbits which is below the infinity, for those, the energy will be taken as negative. And one more thing you must add here, kinetic energy is the negative of total energy. This also you can add here. So at infinity, the energy is zero, right? Now, if your electron, what electron can do, it can move from one energy level to the another energy level. So it can go from lower energy level to higher energy level, or it can come down from higher energy level to the lower energy level. So when it is going from lower energy level to the higher energy level, so what will happen? It will absorb energy, right? So whatever delta E you will get, it will be positive. When it is coming from higher energy level to the lower energy level, energy will be released. And whatever delta E you are getting, it will be negative, right? And how do you calculate delta E? So delta E, we learned that whatever energy plan
Just wait for a second, students. I think there is some technical issue. Please wait for a few seconds. Ma'am has joined. Ma'am, you are on mute.
Hmm. So now what you can do is you can use this formula, or else yes, delta E we know E2 minus E1. So whatever your level you are going to and the level you are going from, so you have to put those energies, right? So let's write it very neatly. So from here you can write delta E as this, right? Now delta E can be written as H nu, or it can be written as delta E is equals to Hc over lambda. What you can write? Hc over lambda. Now from here 1 upon lambda, it can be written as 677 Z square 1 upon Ni square minus 1 upon Nf square. So yes, we can use these formulas to calculate the wave number, right? This is basically the wave number, right? Or this is RH, right? You write it as R or RH, that is your choice. So yes, I can write one So let's write it in a
One by
simpler
one.
way. Yeah, right. So yes, I hope you can do that. Understood? So you can calculate whatever is asked to you by using J. These are just the things that we should know to solve the numerical, right? So just take a look at all these formulas that we have learned till now. And the important part is you must remember the relations. What you should remember? You must remember the relations. These. You may get question based on kinetic energy, total energy, which you have got in previous year, right? If you'll go through the previous year, you will know that you have got question from this portion also. Then of course, this you should know, and this also you must know, right? Now, at least you must know the energies for hydrogen, at least for hydrogen, right? So for hydrogen, what are the energies? If you can remember, it will be very beneficial for you in the exam. So for the first level, it is simply 13.6 because energy is minus 13.6 z square over n square. So both are 1, 1. So yes, I'll get 13.6. So in general, the energies for other atom also I can write E1. So this can be taken as E1 for hydrogen, and then you multiply it by z square over n square. Understood? So for other atoms, for let's suppose if I want to write for lithium 2 positive, then simply put value of E1, which is minus 13.6 z square over n square. So if somebody says you, will see it through the question. If somebody says you that the ground state energy, which is E1 for hydrogen is minus 13.6. So E1 is this much. So you take it there and then you put the value of Z and N. So this is 13.6. Now what's the energy for the second level? Quickly tell me. You have to quickly tell me what is the energy for the second level. Yes, everyone wake up, be attentive, look here, note down the formulas.
Minus 3.4.
Yes. Now what is the difference between the, if I say first excited state and the ground level? What will be the difference in energy if
10.2.
somebody says you,
10.2, ma'am.
yes, it is 10.2. This at least you remember. If not others, but at least this you must remember. That difference in energy for the first, so they can give you in any form. Difference in energy between the second orbit, electron in second orbit and first orbit, ground state and first excited state. So you must know what they are trying to say. Now, what's the energy for third level? Yes,
Minus
what is the energy?
1.31.
Yes, you can type in the chat if possible, right? Minus 1.51, and then here you have minus 0.85. Now also we can see the difference is 1.89, and here the difference is 0.66. This
0.66.
is ground state, which is n equals to 1. This is n equals to 2, n equals to 3, and n equals to 4. So this is first excited state. What I can write? First excited state, second excited state, and third excited state. So this is all that you must know. So shall we begin with the question? Yes, everyone. Are you ready for the questions that have come
Yes,
this
ma'am.
year? Very in last year, last to last year, and many other years, right? So it's important what kind of a questions you are getting in the exam, because there will be lot many things you'll be learning, but we must know, we must have an idea what are we getting in the exam from whatever we are learning. So let's begin with the questions, right? This we did last in the last class, right? So those who were not there, you can take the screenshot and try this question where they were asking about the energy of an electron in first Bohr orbit of H atom is this much. Its energy in the third Bohr orbit is. Then this question also we, yes. Now those who were there in the class, tell me what will be the answer of this question, which is what they were asking. Assume the radius of first Bohr orbit of H atom is zero point 0.6 angstrom. The radius of the third Bohr orbit of helium positive is. Yes, what is the answer that you are getting? So yes, who all were there in the class and also who have seen the recorded session, they must be ready with the answer. So I put the formula also here. Also, you must write down this table, at least you must know for hydrogen. So why I'm emphasizing on keeping the information ready, it becomes easy when you are revising, and also you can directly solve the questions if you have tables with you. That saves a lot of time for other questions, right? These are simply formula based questions. So yes, you can save time in exam for such questions, and then you can spend more time on numericals, which will require more calculation. So yes, everyone. So what it is saying, that assume the radius of first Bohr orbit of H atom is zero point 0.6. So this is basically, so what they are saying is R1 for hydrogen is zero point 0.6 angstrom, right? This is zero point 0.6 angstrom. Now it is asking for the third Bohr orbit. So third
Ma'am,
Bohr orbit for helium positive.
4.761
What's the unit? That is very important.
Armstrong.
Yes. So what will be the answer in picometer? This relation you must know what is the relationship between angstrom and picometer. This I have asked, this I have told you earlier also, right? Do you remember what's the relation between angstrom and picometer? This is picometer, right? Which is the unit for length. Because atoms are very, very small, so we'll be using these units, which is angstrom, picometer, nanometer. Yes, by that time, all of you calculate this. So R3 will be, so N square. This is 3 square. And what is the atomic number of helium? Quickly tell me in the chat.
2.
2, ma'am.
Yes. And then yeah. You should come up with the answer. What is 1 angstrom equals to how many picometers?
10 power minus 8.
My God. You can calculate, right? I'll help you, but I won't tell you the exact answer. Once you first you try. Okay? 1 angstrom, or let's write it like this. 1 meter is equals to 10 raised to the power 10 angstrom, and 1 meter is equals to 10 raised to the power 12 picometer. 1 meter is equals to 10 raised to the power 9 nanometer. Now, again, I don't want in any of the class after this that you must ask me this. Note this down and tell me how many picometer are there in 1 angstrom. So this will be equals to N for hydrogen is 1, Z is also This is first orbit, right? 1, 1. So this will be 0.6. This is 0.6. So these type of question, I have said you already that you have to take it as a ratio. So R1H is equals to,
Ma'am, 10 power
what you will
minus
do? How much it will be?
10 power minus
10
10.
power. So this is your homework. Tomorrow there are today we have so many people, so all of you have to answer this.
Ma'am, it is
Who have got it right?
10
Tell.
square. 10
It will
square.
be,
10 square.
yes, it will be 100. So yes, you must know the answer in picometer also. So it will be 52.9 n square over z picometer. And then in nanometer also you can write the formula, right?
Yes, ma'am.
Yes, what it will be? 0.0529 nanometer, right? So you can write the complete formula. Hmm. So the answer that you must get is 470 picometer. How will you get it? So basically they have given the value of this. This they have taken as 0.6 R1H, right? As I have told you that R1 for hydrogen is Bohr's orbit, which we take as A naught, which is 52.9 picometer, or you say 0.529 angstrom. So yes, they have given you the value of first Bohr orbit. So when I multiply the first Bohr orbit with z square over n, that's when I'll get the radius for other atoms. So it is fixed, right? For hydrogen, it will be fixed. So this will be 0. So in this question, they took it as 0.6 angstrom. So what you can write here is R3 for helium positive will be equals to R1 of hydrogen into 3 square by 2. Now you can do the calculation. Shall we move to the next question? Yes or no?
Yes, ma'am.
Yes, I want answers from everyone. So only Shravani is replying, Omkar, Gayatri, Bhavna, and all of you who are there in the class, you all have to make sure that you are replying in the chat. Yes. So we have Ira, Akshaya, Rosias, right? So you all also have to reply in the chat, right? How others are replying. So keep yourself active. So now let's begin with the previous year questions, right? We'll see some of the previous year question and now you test where whatever you are learning in the class, are you able to apply it in the questions, and what kind of a questions are we getting? Whatever we are learning, is it relevant or not, right? By questions only, we know that whatever we are learning, is it relevant or not, and what portion from what we are learning we must remember and revise again and again, right? So yes, shall we begin with this question? So I hope now you have read this question, which is calculate the lambda. So it is asking wavelength. Okay. Calculate the wavelength of photon emitted when electron. So for electron, I'll be writing this electron in hydrogen atom jumps from first excited state to ground state. Now, do we know the energy? Now these kind of a question, they can be done
Yes.
directly if you remember the energy, right? Yes, we know the value of delta E, right? What is
Yes.
delta
Yes, ma'am.
E here?
H into mu. Planck's
Yes,
constant
it will be a
frequency.
ha. That's that's how we'll write delta E. But what is the value of the energy difference between first excited state and ground state for hydrogen atom? This size, just turn your pages. We did it just now. When we were revising the formulas. Yes, it is 10.2. Now in exam, don't sit there and calculate this. It's better if you remember it from your notes, because yes, they may give that you will have to know the difference between first excited state to the ground state. So in that case, I'll know what is delta E. And let's suppose if you forget that, then obviously you can use the formula. If you remember this, well and good, it will save you some time. Otherwise, how we will do this question? So your delta E will be, so see what it is doing. It is jumps from first excited state to ground state. It is jumping from first excited state to ground state. So here it is going E final minus E initial, right? Is equals to Hc over lambda. Now substitute the values here. So finally, it is going to the ground state. So for ground state, it is 13.6 for hydrogen, because once I put the value of Z square by Ni square, right? Minus, again, I'll take 13.6. Z is 1. So let's put the whole thing, right? So that it's very clear to you. Hc over lambda. Now this is 1. Now Ni, it is going from, sorry, F, we'll take it F
Ma'am,
here.
why
Hmm.
initial energy is taken as 13.3?
Why it is taken as ground state? So let's remove this. Now you have to tell me, why are we taking ground state energy as? Did we learn the formula for energy? If we will
Yes,
keep forgetting
yes,
it, then it
ma'am.
will become
Ground
very
state is
difficult, right?
13.6, but
Huh.
initial state is
Yeah.
3.4.
Yeah. Wait. We'll see the question again, okay? Yeah, ground state is, when I say ground
Minus
state, what would be the
13.6.
value of N? No, first tell me, if I say ground state, then what would be the value of N?
1.
Yes. What will be the value of 1? Oh, what will be the value of N? It will be
1,
1.
1.
When I say first excited state, what's the value of N?
2. 2,
2,
ma'am.
ma'am.
My God, so many answers. Come up with the right answer. When I say first excited state, what should
N
be
is
the
equals to
value?
2.
See, I made you revise everything, right? Now you should not come up with the wrong answers. If I have not made you revise, yes. What should be the value of N?
2, ma'am.
2,
Yes,
ma'am.
equals to 2. Are you sure?
Yes.
Yes,
Yes,
ma'am.
ma'am.
Okay, okay. Now, once you know the value of N, you also know for hydrogen, Z is equals to 1. Now, can't you
Yeah.
substitute the values here? Who was the one who was asking me how did you get the energy? Now, once you know these energies for N equals
Ma'am,
to
I'm
1
not
and
asking
N,
this.
hmm,
I'm asking that initial energy you taken as minus 13.6. How?
you are going from what it is saying, read the question again. From first excited state to ground state.
Yes.
So, initially, where was the electron?
First excited state.
Yeah. So here the value of n you will have to keep as 2, and for this
2,
one you will have to keep the value of n equals to
1.
1. Then just calculate the difference, right? And when it is going from, let's suppose in exam you get the formula wrong, right? You do it as, you take it as putting the value of here as, means you just shuffle the values. So then you have to use your brain that electron is coming from higher energy level to the lower energy level. So energy will be emitted. So whatever answer you are getting, you have to keep it with the negative value, right? Let's suppose that happens in the exam, like you get confused, okay, whether for e final I must take n equals to 1 or n equals to 2. So calculate the energies, take the difference, and see whether you have to put it positive or negative by looking at this. Looking at what? You are seeing that it is coming from first excited state to ground state. That is why I was telling you again and again that whenever we are coming from higher state negative. Now, if I am going from lower energy state to the higher energy state, energy will be positive. Yes, that kind of a confusion can happen in the exam, but yes, you can use the basics. So what will be the difference? This we all know. It will be, how much will be the difference?
10.2.
Yes, it will be. So energy here will be 10.2, right? Now, the one thing that you have to be very careful is this is in electron volt, right? Is it
Yes,
correct?
ma'am.
Now, let's keep the values. What should be the value of H?
6.625 into 10 power
6.626
minus
into 10 to the power of minus
34.
34 joule.
Now, tell me the unit. For me, okay, value it is fine. Everyone can remember. Tell me the unit. I'm not interested in this. I'm interested in knowing the units from you.
Joule.
Joules, ma'am.
Okay. Okay, type your answers in the chat. Let's see how many of you remember what's the unit for Planck constant. Yes. Omkar has got it right. What about others? Bhavna, your answer is wrong. Gayatri, your answer is also wrong. Yes. See, this is not that easy, right? You may understand the things in the class, but then you will forget most of it. So if you'll not revise, this is how you'll get the variety of answers. Now, Ira, right? So that is also wrong. Joule, it's not joule per second. It's Gayatri, it's not joule per second. Just turn your pages and look for the value. Look for the unit. What is the value? What is the unit? So it will be joule second. Now what is the speed of light? 3 into 10 raised to the power 8 meter per second. And this is what you have to calculate. Now again here I'll have to get the energy in joule, right? Because here I am having joule. So anyways, here I have joule second and here I have meter per second, right? That's what I have got. So lambda will be 6.626 into 10 raised to the power minus 34 joule second into 3 into 10 raised to the power 8 meter per second. and that will be 10.2 electron volt. Now you have to tell me, how do I convert this electron volt to joule, or directly you can use the formulas for the energy that we learned for joule, right? And then you can put the value here in joule. Now I have told you the complete thing, the conversions you have to do, because this I have told you in one of the class. How do you go from electron volt to joule? If this you don't remember, then the calculations that you are doing here, use the formula, which is En is equals to minus 3.18 into 10 raised to the power minus 8 z square over n square joule per atom. Use this and then you can do the calculations. Is this clear to everyone? Now you will have to send your answers to ma'am. So let's mark these questions. This is question number 1. Now let's come to the other question, which is for hydrogen atom, energy of electron in first excited state is minus 3.4 electron volt. Kinetic energy of electron of hydrogen atom is x electron volt. Value of x is, yes, this is a very nice question which you have got, I think, in 2023 or 24, which was based on whatever you have learned right now, the formulas that we saw, right? So what it is saying, H atom, so no problem, Z is 1. So whenever you see, first thing you have to do is, okay, Z is 1. Now it is saying first excited state. Yes, this is very easy question, very, very easy. If you remember, if you have paid attention, I'll show you again just to help you see. This is what you have to use. And total energy is, this is what the total energy is, right? En. So what it is saying, that they have given you the energy of the electron in this, right? Now what I told you is kinetic energy is negative of total energy. So kinetic energy is equals to minus 3.4 electron volt. So kinetic energy is equals to 3.4
electron.
right? But they are asking the answer in this. That's how they trick you in JE, okay? They won't ask you the direct answers. So how can I write this? I can write this as 34 divided by 10 electron volt, which can be written as 34 into 10 raised to the power minus 10 electron volt. Your answer should have been 34. And most of the students, first of all, they won't remember this. If they remember this, then they might keep the answer as like this. But you have to be very attentive in the questions for the power of tens. And that's what they do in the questions based on fill in the blanks. Why I'm showing you this question? Just to tell you that what are the things that you have to pay attention to when you are sitting there in the exam and when you are doing the previous year questions. Is this clear to everyone? Pay attention what it is asking, the power of 10, right? And then according to that, you have to write your answer. So what is the answer for this question? Was this easy? So
Yes,
was
yes,
this
ma'am.
question easy? Yes. So these kind of a question you'll get. But yes, this will be only easy once you remember this, that the energy whatever you calculate by using the formula for En, that is the total energy, right? Which is the negative of the kinetic energy, right? And also, yes, if they in this year they gave you question based on this, then again they may give you question based on potential energy. Okay, so what we can write, potential energy is 2 times of total energy. Okay, now do this question.
6.8.
Hmm. What? Who was this
Potential
6.8?
energy.
Okay, okay, you are telling for this question. Okay, no problem. Hmm. Now do this third question. Read it. When a transition in hydrogen spectrum, so this came in last year, right? Should have, which transition is hydrogen spectrum should have the same lambda as the Balmer type transition from n equals to 4 to 2 for helium positive spectrum. Now quickly tell me, all of you in the chat, how many of you can do this question? Tell me by typing yes. Take a screenshot and then just quickly type in the chat how many of you can do this question. So Gayatri, she can do it. Shravani, read the question again and try it. Okay. I will surely tell you, but once you have to get it, that understanding, right? Every time, if I'll explain, then you won't be able to use the concept by yourself. But still, we'll see what we
Ma'am,
have to
answer
do.
is A,
Okay.
option A, right?
Yeah. Hmm. So what you do is, instead of calculating the lambda, what you can do is you can simply calculate the difference in energy, right? Use this formula. Where are the formulas? Yes, this is what you can use. You know what is Ni, you know what is Nf. You put the value of Z for helium positive, right? Once you put the value for hydrogen, or else if you remember what is, okay, so then you will know. You put the value 4 there, you put the value 2 there, and then you will get some energy, and then see, compare with this. That's why I asked you, it's better if you remember this. Because again and again you will get these kind of questions in exam. So you all have to give your fair try for this question and you have to come up with your answer. Yes, answer A is the correct answer. Right? Why they are calling it Balmer type transition? Because the electron is falling to this level, which is n equals to 2. So here, as I have told you, energy, for it is saying E n equals to 4 to n equals to 2. Right here, how you can write delta E minus 13.6 Z square, right? So then you can put the values. So it is going from, initially it was at fourth state and then it was going to the second state. Z for, this is for helium positive. Now, Z for helium is helium. Yes, Z for helium is 2.
2.
Put
2.
the value 2 here. Yes, this is what I can do for you. I can tell you what formula you have to use. Calculate the energy. Compare this energy with the hydrogen spectrum, which we already know, right? Which we already know. You'll get your answer, right? Now, let's come to the next question. Let's see as many questions as we can. Okay, this question. This is not radium, this is radius, right? The radius of second orbit of lithium 2 positive is x. The expected radius of third orbit of beryllium 3 positive is. So this kind of a question we did last time also, right? So yes, for this question, the correct answer is A. Yes, many of you have got the answer also, right? So now let's come to, this was the third question. Let's come to the fourth question. Now, how many of you can do this question? So simply what you have to use is, you have to use this formula, right? 0.529 z square over, sorry, n square by, this is what will happen in the exam. So n square by z is for radius, z by n is for volume over velocity, and energy it is z square by n square, right? So that's what you have to keep in mind. So yes, n square by z. Now see the value. So z and n. Tell me what will be the value of Zn for lithium and for beryllium. Okay.
Z is equals to 3, ma'am, for lithium.
Hmm. N is,
N is equals to 3.
2.
who is this 3? Don't sleep, whoever is this, who is sleeping in the class. Wake up. Okay. For beryllium, what is Z?
4, ma'am.
4, ma'am.
And N here
3.
is 3.
3.
Right? Now calculate the radius. So this is second and this is for lithium positive. And what is the other one? Lithium, just small mistakes you can ignore and correct them. Now 0.529 n square. What is n here?
2.
Yes, 2 square divided by,
3 square.
yeah.
3.
I hope you all can do this question. It's very easy, and these kind of a question they'll repeat. Okay, they'll repeat. Now take the ratios. So basically what it is asking the radius of beryllium in terms of lithium. So the one that is asked, you'll keep it here. And the one that you have to tell in terms of, you'll keep it here. Put these values 0.529, or sometimes don't put this, you can put a naught instead of writing it again and again. So 4 by 3. I hope this time nobody is having that confusion. How did we this go up and this go down, right? I did something wrong, right? Yeah. What for here you will have to put for beryllium. So A naught into 3 into 3, 9 divided by 4. Then again this can be written as A naught, that will be 4, and 3 goes up. This, do we know this? This is X, right? This is X. So R3 for beryllium 3 positive will be equals to A naught, and A naught cancels each other. 9 into 3 is 27. 4 into 4 is 16. And this is X. You take it there. So these kind, why I showed you the calculation, I want to show you how you do these kind of a question. Don't sit there and just, okay, first I'm calculating this, and then what some of the students they do is they calculate this, then they find out, they take the value of a naught by taking it there, and then they put it here. No, when you are asked about the ratios, when you are asked about anything, let it be energy, velocity, or the radius, then you take it like this. You take the ratios, put the values, and then simply you'll get your answer. So these are the steps that you will have to follow. So what is the correct answer here?
Option C, ma'am.
Yes.
Third
So
option.
how was this question? So these are the questions that you have got in JEE in previous years. Okay. So how are the questions? Tell me in the chat. Are you liking the questions or not? Or are they difficult, easy, or moderate? What do you think? Yes, Gayatri, Shravani, Omkar, and who all are there in the class? What do you think? How are the questions? Ashrita,
If
Fozia,
formulas
yeah.
know, it is easy, ma'am.
Yes, if you know remember the formulas, it is easy, and also you have to use your brain completely, right? Should not get confused there, right? They may seem easy now because we are doing them just after this topic, but yes, the same questions they may be little difficult once you are done with lot of syllabus. But how can you make it easy for you? Revise again and again. Also, make sure that you are doing the previous year questions, because that gives you an idea about from which concept they are giving you the most questions, right? So make sure that you are doing lot many questions, and also keep the formulas that are being used in a particular question. For example, in this we were using the radius and then we were taking the ratio. So keep this concept in mind. If this kind of a question comes, then I have to solve it like this. If this kind of a question comes, I have to solve it like this. So when you are doing the revision, make sure that you are also going through some of the questions, different kind of questions. So for your own self, when you are doing the previous year question, mark the questions which are difficult for you. So whenever you are doing the revision, revise those questions also, right? I think I am clear to everyone. Now, okay, this question, longest wavelength, this is lambda, okay? Longest wavelength of light that can be used for ionization of lithium to positive ion is, this is your homework. This is your homework question. So when I say longest wavelength, so basically, if you know the energy, you can calculate the wavelength, right? Can you calculate the energy? This we have done. The relation between ionization energy and the total energy. So you try it, and then tomorrow we'll discuss this question. Let's see what you all do in this question. Okay? Or else we'll keep this question and we'll do this once we learn about the quantum numbers, right? And I'll provide some 2 or 3 more questions to ma'am. So solve them also and make sure you are sending your answer, which you are not doing right now. I don't know why you are not sending your answers. So how many of you are doing the questions that are given to you? I don't think none of you are trying those questions. Yes, everyone. Are you trying those questions which are given to you after the class at some days? Yes. So Bhavna, if you are trying, then why are you not sending the answer? And is everything clear to everyone? You are not having any doubts. You are not sending any doubts to ma'am, which is good that you are able to understand whatever is being taught to you, but still there may be some doubts that you may have. So do ask them. Okay, you can send it to share it with ma'am, and then I'll answer it in the next class. Right? So ask your doubts, solve the questions, and yes, then surely you will be able to do most of the questions in the exam for sure. There is no doubt about that. Okay. So practice as many questions as possible. And yes, some more questions I'll provide based on whatever we have learned. And with this, we have finished this Bohr model. Now, what we will learn first, we'll see just the limitation, and then we will learn about the quantum mechanical model, which is a very important topic, because yes, this forms the foundation of rest of the chemistry, because here we'll be learning about NLM, right? So yes, this forms the foundation, and also it's important from the exams perspective. You may get question from this question. Understood? Is this clear to everyone? Yes, Omkar, why are you not attempting the questions? I am telling you again and again from my experience, you may understand the theory, but you will find it difficult to do the questions if you will not try them after the class. Okay, so most of the students, they will understand whatever is taught in the class, but it may become little difficult if you will not try the questions. So make sure you are trying the questions. The doing the question is the only way to solve the questions that are coming in the exam. Is it clear to everyone? So make sure you are solving the question, sending your answer. I want everybody's answer by tomorrow to this question. You can try this question and also to the questions that I have sent you before, right, for the hydrogen atom, and also I'll be sending some more questions. Okay, with this, I hope you enjoyed today's session by doing these problems and getting an idea like what kind of a questions are we getting in the exam. So now tomorrow we'll finish this, that is the Bohr model, and we'll begin with the developments that led to the quantum mechanical model. Okay, then see you everyone in the tomorrow's class. Be prepared, revise everything. Don't be lazy. Do as many questions as possible, at least the questions that are given to you. And with this, you'll be able to do the question in exam. So see you all in tomorrow's class.
Yes, ma'am. Thank you, ma'am. Yes, students, again we will meet in the evening session, that is from 7 to 9. Okay? So bye everyone. Have a good day.